In the beginning there was earth, paradise, an unspoiled sanctuary of beauty and the only place in the known universe capable of creating and sustaining life. Over time, we hear a lot about increasing carbon dioxide and climate change. As the global temperatures rise and the erratic weather continues across the globe, people around the world are searching for a solution to climate change. One solution into this crisis may be found in the ground beneath our feet.
Nowadays, climate change has become a very hottest topic in the world. So SLM also has an opportunity to address issues related to climate change. For instance, increasing the carbon sequestration and also enabling the soil to store more carbon in the soil.
Soil constitute the most complex and least understood component of terrestrial ecosystems and serve functions vital to humanity such as nutrient supply to plants, regulation of water flow and water quality, and are a major source and sink of greenhouse gases.
Soil, if you see, the soil has been formed through the various process, but basically the main parent material is rock. So it's the weathering of rock which actually produces soil. Along with that, there are another major component which is called the organic matter, which actually makes the soil more functional. And through that, actually it provides a lot of food for the microbes, and also it actually improves the soil physical, chemical and biological properties. Unless we do that, the soil may not be in a position to support all the plants that produce food for us.
Thousands of years of deforestation, drought and land degradation had left our soils in entire shape, and we are accelerating the loss of this essential resource. Many farmers in the developing countries used chemical fertilizers, exclusively urea, to improve soil health, but without knowing the chemistry of nature and the soil.
So when we apply urea, after first 2 years alright, but after third year we find that our soil is very hard. So that's obvious because urea is only chemical mode, it's a salt. Chemical fertilizer, if you add every year, the yield will increase, biomass will increase, and when you harvest most, you don't put back the biomass, then all the nutrients from the soil is going away, and then the microbes in the soil are not getting anything to feed on. Because chemical fertilizer cannot act as feed for the microbes, they need biomass. So if we just keep on chemical fertilizer, applying chemical fertilizer and harvesting, the microbes will not get any food, so the microbes will die, the population will reduce, and if there are no microbes in the soil, your soil is, in our technical term, sterile, which means there's nothing in the soil, and that's the main reason why your soil gets hard, because there are no microbes to process your soil and make them fertile.
When the soil is damaged, it releases carbon dioxide to the atmosphere, and this is how serious consequences for the climate. In fact, many of the world's cultivated soils have lost more than 50% of the original carbon stocks. However, there is a method of how we can put carbon back in the soil where it belongs. Plants capture carbon dioxide and further pump the carbon dioxide down through the root to feed the hungry microorganisms living in the soil.
In a gram of soil, there are millions and millions of microorganisms. Their presence is very important. They are the main ones that are responsible for cycling of carbon cycle, nitrogen cycle. Wherever there are plants growing, the microorganisms thrive. they secrete a lot of enzymes which are responsible for holding the soil particles together, and the enzymes also are responsible for making nutrients available to the plants. So whatever nutrients are available in the soil, which cannot be taken up by the plant directly, by these microorganisms mineralized and then made available to the plant. Microbiology in the soil microbes, are very, very important for generating, converting whatever litter and all this into soil, very fertile soil. So basically we come to ultimately humus. So the microbes are responsible for coming to this, degrading minerals and plants and whatever, and converting into humus, which are ultimately taken up by the plants. So they play a very, very important role in soil microbiology, in soil ecology.
Regardless of the soil of the chemical fertilizers, all plants use the same inorganic forms of fertilizers in the soil.
A fertile soil consists of all the nutrients needed by the plant. For example, we have 18 nutrients, major nutrients and micronutrients. Major nutrients are needed in a large quantity. For example, we have nitrogen, phosphorus and potassium. These are needed in large quantities, and these are very important, essential for the crop growth. Nitrogen basically it is for vigorous growth and green plant to look green, and then phosphorus is for root development, and potassium is for fruit development. These are needed in a large quantity. So a fertile soil will consist of all these nutrients, and then on top of it organic manures. It is very important for a soil to have a good organic manure, because it improves the soil structure, it improves the water holding capacity, it improves the nutrient holding capacity. All the elements needed for a vigorous crop growth to complete the crop cycle. So if these elements are present in the soil, then we call it a fertile soil.
Sometimes this source of nitrogen can be plants called nitrogen fixers. Even the practices like keeping soil covered with plants, increasing crop diversity, composting, intercropping, crop rotation and growing legume plants are proven ways to put carbon back into the soil.
Tomorrow, if you have directives that Bhutan should go fully organic, we have already alternatives to replace chemical fertilizers. Like for nitrogen, urea, we already have nitrogen fixing biofertilizers, nitrogen biofertilizers. By growing legumes is one. Legumes are plants which fix nitrogen from the air, atmospheric nitrogen fixation. So there are certain bacteria in the soil which, with the help of legumes, can fix nitrogen from the air, and then so we can use that as a replacement for nitrogen. There are also organisms called mycorrhiza. These are responsible for making these phosphates which are available in the soil, but they cannot be taken up by the plant. So these microbes called mycorrhiza, when they come in contact with the phosphates, they dissolve them and make them, and because they have very long hyphae, which is spread all over the soil. So when this hyphae come in contact with the phosphates which are lying in the soil, they dissolve them. And then they take it, and where the roots can't reach, the hyphae takes the phosphate from the soil and make it available to the plant. So all these microbes we can isolate, identify from the soil, and then make it in the form of biofertilizer and make it available to our farmers. And another thing is, like I said, by promoting legumes, crops like beans, dal, groundnut, all these are legumes. So wherever you grow them, these plants are responsible for fixing atmospheric nitrogen. Because a lot of nitrogen in the air, but plants cannot take it. So with the help of these legumes, they can trap the nitrogen from the air and make it available in the soil. So the soil fertility will increase. Intercrop with whatever they're growing, especially in vegetables. If you're growing potato, for the first year you grow a legume crop in the field, and whatever nitrogen is fixed by that legume crop is available to the potato crop in next season. That's called intercropping. So we have all the alternatives to supplement and substitute chemical fertilizers.
Fertile and carbon-rich soils act like giant sponges, absorbing water during floods and providing into plants in times of drought, and adding carbon to soil makes the land much more productive. The government of Bhutan recognized this carbon cycle and declared to be one of the carbon neutral or carbon negative country in the world. If every nation could protect our land, then we could pull off more than 75% of atmospheric carbon, enough to make a real difference to our planet's future well-being.
Land degradation is one of the greatest threat, I would say, in terms of socio-economic development, sustainable agriculture, climate change, and conservation of biodiversity. This is simply because through the process of land degradation, it actually emits a lot of greenhouse gases, and which contributes to increasing the greenhouse gas concentration in the atmosphere.
Civilizations rise and fall due to the management of soil. Carbon levels in the atmosphere are at 400 parts per million. However, much of this excess atmospheric carbon can be removed and stored in the carbon-hungry soil through sustainable land management practices.
In order to remain carbon negative, I think sustainable land management has a very big role to play. The reason why I say that is through sustainable land management, there's an opportunity to sequester more carbon and also help the soil to store more carbon in the soil. If I cite one example, in a very steep agriculture land, and if you don't have sustainable land management in place, then especially during monsoon season, most of the topsoils have been washed away, and in the process, the carbon which is sequestered and stored in the soil are been very quickly mineralized, and those soil organic carbon has been released into the atmosphere, which actually contribute to increasing the carbon dioxide concentration in the atmosphere. But if you actually practice various SLM practices, then firstly it would reduce surface land degradation problems in the area. Secondly, by growing suitable plants or crops, that would actually enhance the rate of carbon sequestration, which means it will reduce the concentration of carbon dioxide in the atmosphere.
Large-scale land restoration and effective soil protection are vital for the achievement of many of the sustainable development goals as well as for climate change adaptation and mitigation. Bhutan pledges for restoration and protection of degraded soils can support climate change mitigation through the increase of soil organic carbon.
If you have a very good ground cover and also a very good forest cover, there is less chances of having land degradation problems. And secondly, through the process of photosynthesis, these plants have the capability or the capacity to sequester more carbon. So which means all those forest areas would be the net carbon sink, and which means which would directly or indirectly help our country to remain carbon negative.
Bhutan being located in the fragile Himalayan mountain ecosystem, land degradation is prominent, and it looks like we are going to have a catastrophic effect on the earth's supply of topsoil.
First thing is definitely surface erosion. So again, on the surface we have three types. We have sheet erosion, that uniform removal of the topsoil, that is either by wind, like in Ongdi you see the soil removed by the wind. And the other thing is like uniform removal of soil by water erosion, like a combing or hair. Rill formation, where you get a small drainage type along the fields, which slowly widens up, resulting to gully, then landslide and ravine formation. We have this splash erosion also because of the rain impact. In most of the fields are open without any crop cover, so when there's a drop of rain hitting on the soil, then it splashes the whole, it distorts the soil. And if you go down, then after a surface we have this gully formation, rainwater especially, and even from the damaged irrigation sources, wherever there's water source, if it is not maintained properly, it leads to gully formation. After gully, then we have this landslides, a wider one, which is more catastrophic, and then ultimately ravine, that means whole land must slip and so forth.
This continued loss of the topsoil would not only accelerate climate change but also threaten the food supply.
So in order to stop that, we have to do sustainable land management practices. Based on the locality, we try to do several land management technologies. One is hedgerow plantation. We do counterlines, and then we do the plantation of napier grasses to reduce the surface erosion. And also we do the dryland terracing. It's all based on the locality, based on the ability of the stones. We do the stone bonding. So I think in general we have to think land degradation is not happening in the forest only. We have to do sustainable land management in the farmers' agriculture field.
Definitely in the southern region, I would say, because we being very much close to Cherrapunji, that is the heaviest rainfall in the country, so the rainfall is much higher in the southern belts, especially in the Samduzongkar, Samji, this region. So because beside that we have a flat soils which is very much prone to soil erosion. So the land degradation from point of all these natural calamities could be towards the south, and of course from towards the east, because most of the cropping in the eastern are done on the steep slope. So again the rain aids on that, and the production is reduced to certain extent. But if you come to the west, it's more of comparatively it's flat. So we have a little bit safer side on the western region section.
Bhutan has very strong environmental policies and legislation in place through which land degradation problems and issues can be dealt with. The Sustainable Land Management Project in Bhutan will afford to strengthen and build capacity within the Ministry of Agriculture to systematically and effectively coordinate a program of activities in order to help anticipate and manage land degradation in the country.
From 2005, we have been conducting several land management campaigns throughout Bhutan. So I think in every year we are doing the land management campaign, but the main problem is it takes time for the farmers to understand.
Some people actually tend to think that SLM is all about combating land degradation, but from my perspective, SLM is little more than that. Of course, its first mandate is to combat land degradation, but it also actually addresses or helps our farmers to enhance their livelihoods, and also encourage or helps them to increase their cash income, and in a way it helps to reduce the poverty in the country. And nowadays climate change has become a very hottest topic in the world. So SLM also actually has an opportunity to address issues related to climate change. For instance, increasing the carbon sequestration and also enabling the soil to store more carbon in the soil.
The effects of climate change are already being felt in many communities, and some farmers in Bhutan had already started to implement agricultural crop diversification and landscape architecture-based adaptation measures to climate change.
Ngachi jambuling na name same data digi bi semel. Tenga mi fido chigi jambuling na jurche benidi ngagi be misubhola deberu jamcho na chugi tikpa jumjibe. Ngaragi sachana gyar ani himbe sada bachin ngaragi gekhapda jambuling yonglu te fen thop chubegi lachi ngaragi go chuda bachin te fen mithop ga ase te ani jumje no samtan digi bengagi te tiksing chu digi malema gyar nogi cha di chu te namberu ani hembe denigi grass carpet jumchi bela te ani no samtan digi bengagi ani nogi cha te chudi bi la namberu ani hembera deongla te chu mapalera mebachin ani kam joni gi nengkhayoba देवेवता छु थोपदा बचे नामबेरु अनि हेमबेर देउला ते मिंगुल ngomadira ngaragi खेफेन या जो देले रेखादा जाम्बुलिङ लिया खेफेन जोनिगी थाबलम ngaragi दिबि सिसुनि देवेवता दतोरिङा ते मिनाबे मि बेबे ngaragi लेबगी लाबे दो बेवता नानि बे फेन मिथब गासे ngaragi nomidi ngagina sagona chudi सिसुनि.
Planting trees is one of the most common strategies to remove carbon dioxide from the atmosphere. Planting various tree, shrub and grass species within agricultural landscapes helps to maximize the ecosystem services provided to the adjacent farmland.
If you do the hedgerow plantation, grass plantation in the farmers' field, it serves as a fodder for the farmers. So they don't have to raise the cattle in the forest, which is again there is a land degradation process when there is overgrazing in the forest. So the fodder grasses which grows in the farmers' field, it serves as a soil to reduce the soil degradation, and also it serves as fodder for the cattle.
Bhutan has already moved far and still working to sensitize the people on the importance of combating land degradation and bring some of the vulnerable agricultural lands under sustainable land management practices.
Since we are a party to UNCCD, United Nations to Combat Desertification, we are actually asked to set a target which is called the land degradation neutrality. Each member country is supposed to come up with a plan and programs and also a set target where by 2020 that our country should be land degradation neutral. So in order to achieve that, we are in the process of coming up with various programs in collaboration with our research centers and also the RNA colleagues in the Tsongkhaks. In next couple of months, we should be in the position to come up with clear target areas where we want to carry out sustainable land management activities to combat land degradation. There are also a series of projects coming up which are coming forward or are willing to support all those activities and initiatives. So by 2030, we may not be in a position to really declare that Bhutan is land degradation neutral, but we are hoping that we would achieve a certain percentage whereby we can say that okay, Bhutan has achieved so much in combating land degradation in our country.
Due to the increasing and combined pressure of agricultural and livestock production, urbanization, deforestation, and extreme weather events such as droughts and floods desertify our arable land.
Land degradation means reduction in its productivity and also its potential to provide other ecosystem services. Secondly, it actually declines the productivity of the soil through depletion of soil nutrients, which would affect the sustainable agriculture. Through the process of land degradation, we also actually lose a lot of flora and fauna in the soil, and it has a great effect on conserving the rich biodiversity of our country.
Climate change and our impact upon the environment will determine our future. Anything that we can do to protect land degradation and to increase soil fertility could be a step towards reversing the climate change.
With the limited arable resources we have, land resources we have, I think we are using effectively, because all the agriculturists who are working in the extension centers, they are advising the farmers how to use the land, how to maintain the fertility of soils. Now, what the negative impacts of the applying of the huge fertilizers. So because of that, we are organic centers. We are getting 100% organic in the 2020, and our soil is becoming healthier and healthier with less application of synthetic fertilizers. We are using organic fertilizers to maintain the soils, and this is the way we are going for the sustainability of our future generation.
Our center has the national mandate to make a balanced fertilizer recommendation to the farmers, whereby ensuring that farmers go for balanced fertilization and they don't actually waste a lot of fertilizers by applying unnecessarily in the field, which is not really required. We also encourage our farmers to go for organic amendments because organic farming is slowly picking up in the country. We are also mandated to provide soil information through soil surveys, and we relay all those information to the farmers and other clients through production of reports and through soil maps. The other main mandate of the center is to combat land degradation in the country, and we are the focal agency for the UNCCD, and we are mandated to come up with the best SLM practices in the country to combat land degradation. But not only that, to also enhance the rural livelihoods, also reduce carbon emission to what we call mitigate climate change, and also ensure continuous ecosystem services in the country.
Through sustainable land management practices to improve soil health can directly take excess carbon out of the atmosphere and put it to beneficial use in the soil. It is a solution right under our feet.